So once again, we're going to be talking about what we do with rational numbers, and what we do with rational numbers is the same thing we're going to be doing with rational expressions. And now we're looking at complex fractions. So let's first look at a complex fraction with rational numbers. So here's an example of a complex fraction. And what we want to do is simplify completely so that the top is all one fraction and the bottom is all one fraction, and then we'll simply use our rules of multiplying and or dividing rational numbers. So on the top, 15 is our LCD, and if we simplify this, 3 gets multiplied by a 3, and so we get a 9 minus 5. And on the bottom, our LCD is 3, and so we get 2 minus 3. So there we go. We got one fraction over another fraction. We can simplify this to 4 over 15 divided by minus 1/3. Well, what we have is one fraction divided by another fraction, and we've talked about this. We're going to change that to 4/15 times the reciprocal, which is minus 3 over 1. And so this can be simplified a little bit. The 3 and the 15. And so what we get is minus 4/5. Okay, so that's how we simplify a complex fraction with rational numbers, and we do exactly the same type of idea when we have a complex fraction involving rational expressions. So examples are coming. Here we go. So here's a rational expression, well, complex fraction involving rational expressions. And so I need a common denominator on the top and a common denominator on the bottom. So on the top it's y squared, and I get 1 minus y squared. On the bottom it's y, and I get y plus 1. So make sure you understand that before you go on. And what I'll do now is, instead of dividing, I'll multiply by the reciprocal. So I get 1 minus y squared over y squared times y over y plus 1. So now we're kind of back to where we were with just multiplying two rational expressions. So I factor the top times y over y plus 1, and y plus 1 and y minus 1 are the same, so I can cancel those. I can get rid of that y, I can get rid of the squared, and so what I'm left with now, can you see it? 1 minus y over y. And there you go. So in this problem we're going to get into a little bit of everything. And it's a long problem, but each of the individual steps is pretty simple. So first I'm going to deal with the negative exponents. And I'm going to write this as y over x squared plus x over y squared all over 1 over x squared minus 1 over y squared. So here's my complex fraction. And what I need to do now is get common denominators. I think I can squeeze this in. So on the top, my common denominator is going to be x squared y squared. And I have to multiply this y by y squared and this x by x squared. And so if I do that, what I'm going to get is y cubed plus x cubed all over. Okay? And down here, the common denominator is going to be x squared times y squared. And this one gets multiplied by y squared, and the other one gets multiplied by x squared. So make sure you follow all those steps before we go on. So now what I have is a complex fraction. And what I'm going to do is take the top and multiply by the reciprocal of the bottom. Well, when I do that and multiply by the reciprocal of the bottom, notice what happens. These two terms immediately cancel. How easy is that? Now I have over here x cubed plus y cubed. Remember how that factors? And on the bottom over here, I have y squared minus x squared. That's the difference of two squares. So let's write out what we get now. So this is a good problem because it reminds you about different types of factoring. Here is how the sum of two cubes factors, and here's how the difference of two squares factors. And so what I can do now is simplify, and x plus y and y plus x are the same, and so finally I'm left with x squared minus xy plus y squared all over y minus x. And there you go. That was a long problem, but each little step should be doable. Alright, so that finishes this section. See you next time. Keep working hard.